Okay. Last lecture, what we have discussing? Last lecture, what we have discussing? Operands, right? I guess I have covered till this point. Operands, data types we have covered, then operators we have covered, right? And now today, we will start our discussion with this, that is operands. Okay. Okay. Now, what do you mean by operands? Right. Now you have clear with the difference between operators and operands. Okay. Operators means what? The process or the operation that you want to perform, right? It may be a arithmetic operation, or it may be a logical operation. It may be some relational operation, right? Such as greater than, less than, equal to, greater than or equal to, etc. So this is about the operators. Now, what do you mean by operands? Can anyone? What do you mean by operands?
A variable on which operation is performed.
Very right, very right. The variables on which, right, that user defined variables on which that operation has to perform, right? तुम्हाला बेरीज करायची, पण कुणाची बेरीज करायची ते पण लिहावं लागणार का नाही? ए आणि बी ची बेरीज करायची. मग ए आणि बी हे काय झाले या केसमध्ये? ऑपरंड्स, राईट? सो सिमिलरली in case of Verilog, there are operands, and that we are going to discuss now. Now the first one is a literals. Now what do you mean by literals? Literals are constant valued operands that can be used in Verilog expressions, right? Literals the constant value operand. So you can treat literals as a constant only, right? Literals and the constants are one and the same thing. So these literals are the constant value operands that can be used in Verilog expression. So this is the example that you can see. So this is the time is. So it's a string literal. Then 20 apostrophe H B365. So it's mean it's a 20-bit hexadecimal number. And what is that number? B36F. So it's a 20-bit hexadecimal number. Then it's a apostrophe O 62 bits. Simply it means it's a 32-bit octal number, that is 62. It's a 32-bit octal number. Then 2 apostrophe B01, that means it's a 2-bit binary number, and which is that 0 and 1. So simply if we have written 267, so that will treat as a 32-bit decimal number, right? So in these many ways you can actually use the literals operand in Verilog expression. Okay. Now wires, registers, and parameters. Now what do you mean by this wires, registers, and parameters? It can also be used as operands in Verilog expression. These data objects are described in next section. So what do you mean by these wires, registers, parameters? So you can use this as an operand also, and how to use that we will discuss in our later discussion. Okay, so this is about wire discussion. Now next is a bit select. Now this is another type of operand, bit select. What is this bit select? Bit select and part select are selection of a single bit and group of bits respectively. That means if you use bit select, then it's a single bit, and if you use part select, then it will be a group of bits that you can use from the wire, register, or parameters vector using square bracket. Means, see, you can go through these examples. Register in square bracket 7 as to 0, a comma b. What it means? It means a and b are the 0 to 7, that means 8-bit number, right? A and B are the two 8-bit number register, or A and B are the two 8-bit registers that you are using, right? So in this way you can what we can say, simply mention the bit select value. Similarly, in this way, C is equal to A7. That means it's a single bit and that is of 7th number. It's a 7th number single bit. Similarly, B7. That means again in that B register, it's a 7th bit. That is a single bit, right? Similarly, how to use this part select, that means group of bit, in this way. A7 as to 4. That means A is 4-bit number from and its LSB is a 4th number place and MSB is a 7th number place, right? So again B3 as 3 as to 0. That means B is also a 4-bit number, and what we can say, it's a 4-bit number. So in this way you can use this bit select and part select. Then next type is function calls. Now what it means, the return value of a function can be used directly in an expression without first assigning it to a register. That means whatever the return value of this function, and that you can use directly in an expression without first assigning it to the register or wire or variable. How to use that? Now first we have to discuss its syntax. The syntax for this function call is like this: function name, then argument list. So how to use this? So here function, then this chk underscore bc is a function name or function definition, and then you can have the argument list. That means input c comma b, then clock. So this is the argument list, okay, and this is the function name. So in this way you can use the function calls. Now this is about the operands, right? So this is about the operands. Now we will discuss the next part of Verilog programming, that is modules. What do you mean by modules? Now module declaration, right? A module is a principal design entity in a Verilog, right? So as in our VHDL, to design the input output ports, what we were using, entity, that port declaration or generic declaration, right? Similarly, in the same context, in Verilog we have that modules declaration. In that you can define and design the entity of your design in Verilog, right? In Verilog, by using that module declaration, you can design and define the entity part in Verilog programming, right? So the first line of module declaration specifies the name and port list. That means how many inputs, how many outputs you are requiring. So in first part you have to define that. Then the next few lines, it may be specify the input output types. That means whether it is in out or means bidirectional or simply input or simply output, and width of each port, and along with if your particular input is more than 1 bit, then you have to define its width also. Similarly we are doing in VHDL, right? That bit vector we are using, bit vector 7 down to 0 means it's a 8-bit input. It's a 8-bit input. So in that way you can define by using modules in Verilog. So here is the syntax for defining module. So you have module name, right? Then port list, that means what are the input output pins you are defining. Then input output and in out with its range or with its what we can say, the value, right? Length you can say. So it is about the module, okay? You can so in this case, suppose you have this design with you. You have add, then input 1, input 2 and output 2. That means in this case you have the 3 inputs and 1 outputs. Now how you can define in Verilog? So first you have to write module, then module name, then add underscore sub. So this is the module name and this is the port list. So we are using the 4 ports, add in1, in2, and OOT. So these are the 4 ports we have defined. Now this add is of single bit only. So input add, we haven't declared any range because it's a single bit. Then this input 1 and input 2 is of 8 bit. Then how to declare this? Input 7 as to 0 means in VHDL how we are writing here, input bit vector 7 down to 0. In Verilog simply you have to write the input and in square bracket 7 as to 0. That means it's a 8 bit input, IN1, IN2, right? And wire IN1 comma IN2. That means this IN1 and IN2 you can use as a wire, or it is of operand type wire, and this output is also of 8 bit. So this output is 8 bit and it's a type register. That means the output is 8 bit register, and these say 8 bit inputs are acting as a wire. That means there are 8 input wires for input 1 and there are 8 input wires for input 2 and end module. So this is the what we can say basic use of module to start your Verilog program. To start your Verilog program. Now next is continuous assignment statement, right? The same we have discussed in VHDL also. Continuous assignment statement. What it means? The continuous assignment is used to assign a value to a wire in a module. That means this continuous assignment statement is used to assign a value onto a wire in a module. That means you have declared the input output variables, but if you want to declare that particular input as a wire, then you have to use this continuous assignment statement. That means how to use that? Its syntax is wire, then wire variable, then value, then assign, again wire variable, and the expression. Means you can look at this example. This wire 1 as to 0a is of 2-bit value. That means it's a value, and we are defining it's a is a 2-bit wire. And what is its value? A is equal to 2-bit 0 and 1, right? So it's a value of this wire 0 and 1. Now assign B is equal to C and D. That means you have to using this assignment statement, B will get C ANDed with D, and assign D is equal to X or Y. Assign D is C. We have studied this. This symbol is of OR, right? So it is X or Y, right? So in order to assign this, what we can say, different wire statement, you can use this continuous assignment statement, right? You can use this continuous assignment statement. So this is how you can use this continuous assignment statement. Now the next we will discuss about the parameter modules, parameterized modules. What it means? You can build modules that are parameterized and specify the value of parameter at each instances of module. That means we can use this parameterized module that can be parameterized and specify the value of parameter at each instantaneous of the modules. That means at each instant as the module produces, you can write the parameterized instantiations. That means you can look at this example. This is the module part. Okay, module shift underscore n is the module name. It is the port that we are using, IT and OT. Again, input output we have defined here. Then parameter n is equal to 2. It is also defined here, so we are using it as a constant. Then assign OT is equal to IT, right? And it's a left shift n times. IT left shift n times and end module. Now you have to declare this parameterized instantaneous. That means this wire 7 down to 0, IN1, OT1, OT2, OT3, and this shift n, this code or this part of code that you have written, it's called as parameterized instantiations, parameterized instantiations. So this is about the parameterized instantiations. Now and remember, synthesis tool does not support the this deparameterized keyword. Okay, so you have to write the instance name associated with the parameter. This means it is not the keyword. This keyword diff param. This is not the keyword that Verilog will consider. So you have to use the statement of this df param to what we can say, to help the compiler to identify it is a parameterized instantiations. Okay, so this is the syntax for this parameterized instantiations. Its instance value dot parameter is equal to parameter value. That means whatever new value you want to assign, so it's about the new parameter value, right? Now next thing is behavioral models, right? So as we have studied in VHDL, we can code or we can design our architecture by using three modules: behavioral, structural, and data flow. Now the same also, not three, but we can have the behavioral model and the data flow model in case of Verilog. Behavioral model and the uh, data flow model in case of Verilog. Structural model is hardly used. Structural model is hardly used in data flow model. म्हणजे मेन मॉडेल कुठलं यूज होतं व्हेरिलॉग मध्ये? बिहेवियरल मॉडेल. पण व्हीएचडीएल मध्ये तसं नाही. व्हीएचडीएल मध्ये आपण तिन्ही मॉडेल यूज करू शकतो, अँड दॅट टू बी अ व्हेरी प्रॉमिनंटली, राईट. बट इन केस ऑफ व्हेरिलॉग, बिहेवियरल मॉडेल, राईट, अँड देन द व्हॉट वी कॅन से द स्ट्रक्चरल. इथे पण तीन मॉडेल असतात, पण मोस्ट प्रॉमिनंटली जास्त कुठलं यूज केलं जातं तर बिहेवियरल, राईट. त्याच्यानंतर स्ट्रक्चरल, अँड डेटा फ्लो इज लिस्ट यूज. Data flow is least used. So this is about the different modelings. Then procedural assignment statement, right? So in that behavioral model, we have studied the process statement in VHDL. Now here we have to study the procedural assignment statement. Now what it means? These procedural assignments are the assignment statement used within the Verilog procedures. That means as this what we can say, in VHDL we are using the process statement, that is a concurrent. So in case of Verilog we have the block statement, right? Different block statement, and that will execute concurrently in case of Verilog. Now these procedural assignment statements are the statement which used within a Verilog procedures. That means always and initial blocks. So this always and initial blocks, these two are the procedural assignment statement used in Verilog. And only register variables and integer can be used and can be placed left to the procedural assignment statements. Means either you have to mention the register or integer, or both register and integer can be placed left to the equal to sign in procedures. Okay, so again we will discuss this, how to use this procedural assignment statement and all that more in detail in our later discussion. Now delay in assignments. Again, if you want to insert some delay in your programming, you have to use this delay assignment statement, right? And again, it is not for synthesis, it is only for the simulation purpose, right? While discussing the I was demonstrating you that programming part in Xiling tool, you might have seen wait for 10 nanoseconds. That means that delay I have inserted, right? So in your design or while simulation or while simulating your design, if you want to insert some delay, then you can use this delay assignment statement, right? You can use this delay assignment statement, and the syntax for it is delayed assignment. Then how much delay that you want to insert, its variable and its expression. So in this way you can write the delay assignments. Now intra assignment delay. That means within two assignment, if you want to insert some delay, so this is the syntax for that intra assignment delay, right? So in this way you can use this what we can say, the value of the delay assignment segment. For example, so it's a variable, that means it's a uh, zilth, so it's a variable name, that means it's a delay name. Its value is 15, right? Its value is 15 times, and expression is this ckz ended with h. So in this way you can use this delay assignment statement, right? The next part is blocking assignment statement. Now how to use this blocking assignment statement? The procedural blocking, always remember the blocking and always the blocking and always, these two are the types of procedural assignment statement. Blocking and uh, always, these are the two types of procedural assignment statement, and these both are concurrently executed. Okay, now this blocking assignment statement, that means are done sequentially in order the statements are written. That means whatever the comes under that block statement, it will get executed sequentially, right? But whatever the comes in that always statement, it will get executed concurrently. That means this always statement, it has to get executed concurrently, and whatever the inside that always statement, again it has be a it has to be a sequential one. Okay, so this is about the blocking statement and how to use that. So these are the some examples. So always at the rate this positive age clock begin, and this is the expression that you have written. So in this way you can this blocking assignment statement. Then there is a non-blocking assignment statement, right? So when to use this blocking and when to use this non-assignment statement, that I will clarify you. Normally this blocking statement this non-blocking statement can be used for a combinational design, and this blocking statement can be used for a sequential design. This is the only difference. Non-blocking combinational design, and blocking for sequential design. Now this is the symbol for this non-blocking assignment statement. This arrow, directional arrow, this is the symbol for this non-blocking assignment statement. And you have to what we can say, use this symbol by to design any non-blocking assignment statement. Means whenever the compiler will find this symbol, it will automatically understood that this is a non-blocking assignment statement. बरोबर आहे. कंपायलरला हा सिम्बॉल दिसला रे दिसला की इट विल आयडेंटिफाय इट्स अ नॉन ब्लॉकिंग असाइनमेंट स्टेटमेंट. So the syntax for this non-blocking assignment statement is non-blocking, then variable, then this symbol is very very important. All right, directional arrow followed by equal to sign. Then you have to write the expression, then again variable, then the same symbol, then again expression. In this way you can use this non-blocking assignment statement, right? So here is example: initial, then begin, then this is the variable, and this is the non-blocking assignment statement symbol, and it's again expression. That means a, what it will do, it will grab a at t is equal to 0 and deliver b at t is equal to 3. That means it will grab a value at 0th time and it will pass that value, or it will deliver to the b after 3. That means when the time will reach to the 3, it may be a microsecond, nanosecond, or millisecond, that you have defined, whatever you will define in that way. So it will deliver a value to the b. So it's about the non-blocking assignment. Okay, now in this way you can use this blocking and non-blocking. Always remember, blocking assignment statement mostly used for the combinational logic design. Non-blocking assignment statements mostly used for the combinational design, and the blocking assignment statements are mostly used for the sequential logic design, right? So begin and end, right? So again, these are the two very important lines that you have to written. Simply, begin and end block statements are used to group several statements for use where one statement is synthetically allowed. That means whenever you will write the begin, right? So from that, your code will start executing. Whenever you write end, the execution will stop. And in between this begin and end, you can write many such a different blocks or many such a different small codes so that you can have the entire design, right? Begin म्हणजे काय, सुरू करणे. End म्हणजे काय, थांबवणे. मग या बिगिन आणि एंडच्या मध्ये you can write what we can say n number of small codes. You can write n number of small codes. So this is the use of begin and end. Now again, the for loop, the same way you are using in C language, the same way we are writing here also. बरोबर आहे. सी मध्ये फॉर लूप असाच लिहिता का नाही तुम्ही, फॉर j is equal to 0, whatever variable you have defined. For j is equal to 0, j will receive the value 7 and j is equal to j plus 1. ह्या सेम वे मध्ये तुम्ही सी लँग्वेज मध्ये फॉर लूप लिहिता. In the same way, you have to write this for loop in Verilog also. That's why I have mentioned at the beginning of this Verilog, it's much similar to the C language. It's much similar to the C language. Now, this is the syntax for this for loop. For, then count, then its value, and count maybe greater than or equal to, or less than or equal to, whatever you have defined. Then count is equal to count plus or minus the step. So in this way, you can write the or you can use the for loop, right? So example is this: for j is equal to 0, that means count, j is a count, then j is less than or equal to 7. This is the condition we have written, and action is j is equal to j plus 1. That means j will increment by 1 unless and until its value is less than 7. So in this way, you have to write the for loop. Then same about the while loop, right? So the while loop repeated until the expression to false. That means while this is the condition, begin, this is the loop. That means this loop will get executing unless and until this condition will satisfy, right? This condition will satisfy till time this loop, right? This loop will keep on executing. This loop will keep on executing unless and until this expression is true. That means this expression is not getting false or not evaluate to false, and that for that much time and for that much number, this loop will keep on executing. So this is about the while loops. Now forever loops. Now what do you mean by this forever loops? The forever statement executes an infinite loop of a statement or a block of statement to avoid combinational feedback during synthesis. That means this forever statements execute an infinite loop of a statement or a block of statement to avoid combinational feedback during synthesis, right? So this is the purpose of using this forever loop. This forever begin, and this is the statements that we have written. If you want to execute this loop infinitely, right, it will execute this loop for infinite time, right? So this forever, because the name itself indicates forever, you have to execute this loop. That means there is no condition or limit for this loop to execute it. That means for how many times this loop will execute, there is no condition. It will keep on executing infinite time. So for that purpose, you require this forever loop. Now repeat. Now this repeat action, this repeat statement execute a statement or block of statement a fixed number of times. That means if you want that statement to execute for just say 5 number of times without any condition, but the what we can say the repetition time is fixed. इथे आपण कुठली कंडिशन देत नाहीये की ही कंडिशन झाली तरच तो लूप एक्झिक्यूट कर, अशी कंडिशन नाहीये. तुम्हाला तो लूप एक्झिक्यूटच करायचा आहे पण 5च वेळा, तर तुम्ही रिपीट वापरायचं. तुम्हाला तर तो लूप जर का इन्फायनाइट टाइम एक्झिक्यूट करायचा आहे, फॉर एव्हर स्टेटमेंट वापरायचं. आणि तुम्हाला तर तो लूप जर का कंडिशन व्हॅलिड होईपर्यंतच एक्झिक्यूट करायचा आहे तर व्हाईल लूप वापरायचा. आणि अगेन फॉर लूपला पण कंडिशन असते, त्यामुळे फॉर लूप आणि व्हाईल लूप हे कंडिशन साठी, फॉर एव्हर लूप हा इन्फायनाइट नंबर ऑफ टाइम साठी, आणि रिपीट हा ठराविक व्हॉट वी कॅन से ठराविक नंबर साठीच, इररिस्पेक्टिव्ह ऑफ द कंडिशन. म्हणजे इथे कंडिशन काय मेन्शन केलेलं नाहीये, पण तो किती वेळा लूप एक्झिक्यूट व्हायचा ते तुम्ही मेन्शन केलंय, राईट. So this is the difference between for loop, while loop, forever loop and repeat loop. That means now in this case this loop will executed for only 2 times, for only 2 times. So this is about the repeat statement. Now this disable statement, what this statement will do, execution of disable statement terminates a block and passes a control to the next statement after the block. That means similarly that we are using in VHDL, which statement we are using, next statement, right? Next statement, what next statement will do, it will terminate the execute and it will jump on to the next line. So in this Verilog, the disable statement will do that job. Its syntax is disable block name. That means whatever the you have written this disable block name, so it will terminate the execution of that block and it will jump on to the next statement after that block. बरोबर आहे, म्हणजे तो त्या ब्लॉकचं एक्झिक्युशन थांबवतो and it will exit that block and it will start executing the first statement outside that block. So in this way this disable statement you can use. Now next loop is if else, right? Else if loop. So again need not to even explain these things, so you have used this many time and you have learned these things many time while studying the C and data structures and all that. How to use if else loop? If the condition begin statement end, if that condition is not valid then else if, and finally else, right? So for if else loop the methodology is same that we have used in VHDL programming. Now you can see this example. If this condition is satisfied, then do this thing. If not, then else if. Now it will check for this condition. If this condition satisfied, this statement will get executed. If this condition is not satisfied, then it will jump on to next else if. It will check for this condition. Now if this condition is satisfied, well, it will execute this line and it will enter the loop. If this condition is it will exit the loop, and if this condition is not satisfied, then again it will go to the last condition and it will execute this last condition, or it will execute this last statement. So in this way this if else loop will execute. Then again here is also case statement, right? The same thing we have studied in VHDL also. Now this case statement allows a multipath branch based on comparing the expression with the list of case choices. That means this case statement, whatever you will expression you will write with that case statement, so that many variables you can use right later on and you can execute that. Means for example case expression means in bracket you have to write the different variables that you have to use. Then case choice first, you can take any variable in that entire case statement, it will be your choice first. Begin, you can write some expression or statements and you have to end. Then similarly case choice 2, begin you have a group of statement and you have to end the case loop. Then similarly more choices, again you have to write with the same manner. And so in by using this case expression you can have such a n number of ways. For example, you can see here this case ALU underscore CTR. Now this same thing you can here only we have defined the one expression only, but with this you can write such a many case statements. You can write such a many case statement, right? And after begin you have the different group of statements, right? So in this way you can use the case statement. Now case X statement. Now what this case X statement will do? In the case X statement, the case choices constant A may contain ZX or question mark. That means in the place of that expression, you can have this constant. For example, case X, case Z, or case question mark. Now what it means? Now it don't cares for the comparison. With case, the corresponding simulation variable would have a match, a tri-state, unknown, or other signal. That means that Z is nothing but impedance. That means match. X is nothing but unknown, and that question mark represents the other signal or either signal. That means Z is a tri-state match. X is a unknown, and that question mark is a either signal. That means it can be a unknown or it can be a tri-state signal. So in that way you can use this case X statement, right? So example is here, case XA. That means you have used this unknown mark. That means this A variable is unknown case. Its value you don't know, right? This case X, that means case unknown, and its variable is A. That indicates this A variable has unknown value. This A variable has unknown value. And now you can write the statement in front of that. For example, 2-bit 1 comma X. That means this X is unknown, that we have to find. And this MSB is equal to 1, right? That means this MSB is of 1 value, but this LSB, that means X, is a unknown. Similarly, you can use case Z, right? Case Z, that means tri-state, right? Or what we can say, the impedance. Now, how to use this case Z statement? Case Z is the same as a case X, except only it will, what we can say, and something with the high impedance. That means this can use case Z is favored over case X, since in simulation and inadvertently X signal. That means it will not matched by 0 or 1 in a case choice. For example, you have this case Z statement and case Z is D. That means this D variable is tri-stated. This D variable is tri-stated and its value is 100 or greater. That means in our case we have used that example. You can use anything. For example, 3 bits value. That means this 1 and this question mark is a 3 bits value. And B is a second variable. It's a 2-bit, that is 1 1. That means B is a 2-bit variable, right? And if D, that D is a unknown 3-bit variable and its 2 bits are unknown. Its 2 bits are unknown. That means this is the case for this D, and we have mentioned the B clearly. Now what it will do? B is equal to 1 1 if D is equal to 100 or greater. B is equal to 100 or greater. That means if you want to mention a threshold for something, that means if suppose do this, if this value is 100 or anything greater than that, then in that case you can use this what we can say, this case Z statement. Then you can use this case Z statement. Now timing controls, right? Next part we will discuss the timing controls in Verilog. So delay control, the first one is delay control. Already we have discussed this part. So it is not used for the synthesis purpose. It is always used for the simulation purpose, right? Now you can check the syntax for this timing control. Hash, then delay, then statement. That means hash 5. That means this 5 is a delay. And what is the statement? A is equal to B plus C. That means after 5 times you need A will add B and C and it will get stored into A. That means after 5 times unit, A will add B and C and it will get stored into A. So in this way, you can use this delay control statement. Then you can have the event control statement, right? If you have to control the event similar to the process statement, then you can have this event control statement, right? What its syntax? म्हणजे आपण VHDL मध्ये इव्हेंट कंट्रोल वापरत होतो का नाही, इफ क्लॉक टिक इव्हेंट अँड क्लॉक इज इक्वल टू 1 असं आपण लिहित होतो का नाही, तसं व्हेरिलॉग मध्ये आता क्लॉक टिक इव्हेंट आणि क्लॉक हे नसतं. व्हेरिलॉग मध्ये काय असतं, that this syntax @ POSEDG, that means positive age variable, or you can have the negative age variable. आपण VHDL मध्ये कसं लिहायचो, if clock tick event and clock is equal to 1. इथे तसं नाही लिहिणार. इथे कसं लिहायचं तुम्ही, @ पॉझिटिव्ह एज. दॅट मीन्स जर का त्या क्लॉकची पॉझिटिव्ह एज आली तर काय करायचं, यू कॅन राईट दिस एक्सप्रेशन, राईट. फॉर एक्झाम्पल, ऑलवेज @ पॉस एज म्हणजे पॉझिटिव्ह एज क्लॉक और निगेटिव्ह रिसेट, राईट. म्हणजे ही कंडिशन जर का झाली तर काय करणार, इफ रिसेट इज इक्वल टू Q, 0 एल्स Q इज इक्वल टू D. म्हणजे ही कंडिशन सॅटिस्फाय झाली आणि इफ रिसेट जर का ट्रिगर झाला असेल, म्हणजे इफ रिसेट इज ट्रिगर्ड, देन Q will get value 0, else Q will get value D, right? So in this way you can write this what we can say, the event control. Similarly, @ A or B or C, right? That means when this A ORed with B and ORed with C, this condition will satisfy, then what will happen, sum is equal to A plus B plus E, then this statement will get executed. So you can see this @ means what, you have mentioning some event condition, means this event is happened, then do this job. If this event is happened, then execute the next line. So it's about the @ will act as an event control, right? This symbol is used for the event control, right? So this is the, now again we have the wait statement, as we have studied in a what we can say, VHDL. So in Verilog also we have wait statement. What it will do, delay executing the statement following wait until the specified condition evaluates to true. That means it will wait on that same line unless and until that condition get verified or that condition get true, right? For that much time it will वेट ऑन द सेम लाईन. आपण VHDL मध्ये हेच शिकलोय. वेट स्टेटमेंट काय करतं, ती कंडिशन जोपर्यंत ट्रू होत नाही तोपर्यंत एक्झिक्युशन तिथं होल्ड करतं, बरोबर आहे. अँड वन्स द कंडिशन विल गेट ट्रू, देन इट विल स्टार्ट what executing the next line. So here also the job of this wait statement is same, right? Now next is intra assignment delay. Now what do you mean by this intra assignment delay? This delay is placed after the equal sign. The left hand assignment is delayed by a specified time units. For example, this is the always, this is the event statement we have used, right? Always this positive clock means this event is not happening. Then if this event is happen, then what we have to do, then B is equal to #5A. That means A will get, A is equal to B, means this both value will get transferred after 5 times unit, after 5 times unit. Similarly, C is equal to #5B. That means B was grabbed in the parallel procedure before the first procedure changed A. That means similarly, when this positive age happens, then after 5 times, first the A and B, they will get equal, and then the B value will pass to the C value, and this C will get equal to B, right? That means if you want to pass a value of certain variable to some other variable with some delay, then you have to write this intra assignment delay. You have to write this intra assignment delay statement. Now about the procedures, this always block and initial block. So these are the two procedures that most commonly used in a into a Verilog, this always and initial block. Okay, so this part we will discuss in tomorrow's lecture. Okay, today we will stop here. Regarding today's session, if you have any doubt, you can ask me right now. आतापर्यंत काही तुम्हाला कळलं नाहीये तर विचारा. From tomorrow lecture, we will start our discussion with this procedure. कळलंय सगळं?
Yes.
Okay, fine. We will stop here today. Thank you.